Okay, so today's topic, it's actually an extension from what you have learned in your semester 1, your ideal gas law, right? So from ideal gas law, so how are we going to apply them in thermodynamics processes? Okay, so today we will be going into first law of thermodynamics. So before we start to learn something new, why don't we recall what we have learned in ideal gas? So can anyone type on the chat, what is ideal gas law? When you look at this term, what comes to your mind? Or any equation? PV equals to PV, quite near. Yes, PV equals to nRT, very good. Okay, so the ideal gas law equation the forever popular equation, regardless in physics or chemistry, you will encounter this equation, which is PV equals to nRT, or capital N KT. So what does P stands for? P stands for pressure in the unit of Pascal. V stands for volume, meter cube. So this V is a capital letter V. Yeah? The small capital V velocity stands for velocity, right? So big capital V is always for volume. Small capital N, number of mole. R is gas constant. The value is 8.31 joule per mole per Kelvin. Okay, and this T is temperature. So what is the unit of temperature? The SI unit of temperature. Kelvin, huh? Okay, super duper important because we are so used with because we are so used with degrees Celsius. Okay, so whenever comes to SI unit, remember the SI unit for temperature is always in Kelvin. Okay, how about the other side? On the other side, the big capital N, this one, the big capital N, this is correct, huh? Number of molecules. The small capital K is the Boltzmann constant. (1.38 times 10 to the power of negative 23 joule per Kelvin, and this capital T is temperature. Okay, so for your case, usually we will use the from part only. PV equals to nRT for our ideal gas law equation, right? So for most of the time, when it comes to thermodynamics, if the question mentioned is an ideal gas, then this formula apply. Okay, otherwise if the question does not mention it is an ideal gas, then usually we don't apply this. Okay, so let's look at the learning outcomes today. So at the end of the session, you will be able to mention about the first law of thermodynamics, and we will use this to solve problems. And we will also learn 4 types of thermodynamics processes. Okay, so they are isothermal, isobaric, isochoric, and adiabatic processes. Okay, calculate the work done to find the internal energy, to find the heat of the thermodynamic processes. Okay, so basically there are 2 main things here. One is the first law of thermodynamics, and another one is about the processes. And after that is the combination, okay, between the first law of thermodynamics and also the processes. Alright, so the first terms that you have to know today is internal energy. Okay, so internal energy is the lump sum energy, the energy in lump sum, okay, that associated with the atoms and molecules of the system. So we know this one is applicable for gas only. Yeah? So for thermodynamics, it's all for gas. So we know that, let's say this is a space. So gas consists of all the atoms or molecules, and the distance between the molecules are very far away, right? And they are moving vigorously. Okay, so this internal energy is all types of energy that contains by all the molecules, so including of all the kinetic and also potential energy that owns by the molecule. So that's why I say it's the lump sum energy that owns by all the molecule inside here. So this is what we call as internal energy. Alright, so this internal energy depends on the temperature. So you imagine when you have higher temperature, isn't it your molecule is moving faster? Okay, so it actually depends on the temperature. So the internal energy, the formula for internal energy is given by 3/2 nRT. So again, this is something that is, okay, this is the most common equation. From ideal gas equation also, PV is also equals to nKT. So that's why it can also be equals to this one. However, in your syllabus again, these 2 are the more common types of calculation that will be in use. Okay, so can you tell me the internal energy of an ideal gas now depends on which one? A, B, C, D.
C.
D. Yeah, because U equals to, yes, is depending on temperature. However, nRT also equals to PV. So volume, yes. Pressure, yes. Temperature, yes. So all of above, right? So they are actually interrelated. Now look at the work done on the gas or by the gas. Okay, so if you have remember in your what you have learned in your first semester, work done is equals to force times distance, right? So if there is a displacement, when there is a displacement, there is work done. Okay, so work is only done when there is a change in the distance. So same goes with thermodynamics. Work is only considered as done when there is a change in the volume. Okay, so if there is no change in volume, then there is no work done. Okay, so if you look at the two pistons here, okay, so this is initial step and this is the final step. So there is a change in the volume of this. So there is work done. So when it comes to first law of thermodynamics, so instead of you learn about the equation, we also look at the sign convention. Okay, so if the gas is doing the work, this is our system, yeah, inside. If the gas is doing the work, means it is expansion. So gas is working hard in order to grow bigger. Okay, so work done by the gas. So it will be positive in the sign, okay, in the sign convention. So if the work is done on the gas, means the gas is being suppressed, so it's compression. Okay, then it will be negative work done. Okay, so this sign convention you have to memorize, yeah? Right? So even though in your exam you can write them in your own formula sheet, I would encourage you to memorize them now, right? Because you will still need it in your degree letters, especially if you are going for chemical engineering and also mechanical engineering. So these two will definitely deal with thermodynamics a lot. So my advice is memorize them. Not much to memorize, okay? So if you are doing the work, so if the gas is doing the work, you have positive, okay? If something if the surrounding is doing the work on the gas, okay, you are being suppressed passively, then it will be negative work done. So now let's look at what is first law of thermodynamics. Okay, definition of first law of thermodynamics. So when a small amount of thermal energy, Q, or what we call as the heat energy, is given to a gas, so the gas will absorb that energy and use it to increase its internal energy and to do work. So for example, let's say okay, piston. If you have done this in your high school before, so let's say if this is a piston, yeah, I draw like this, huh? Let's say if this is your piston with an adjustable pump here. Okay, so when you heat up the gas in the piston, what happens is the heat from the fire, okay, will be given to the gas, right? So when the gas receives the heat, what the gas will do, okay, it will use to increase the internal energy as well as to do the work, right? To do the work, let's say if what will happen, it will cause an expansion, right? Expansion means there will be increase in volume. So by right, Q from the fire will be given to the gas to increase the internal energy and to do work, right? So we will rearrange the equation and make them into this. Delta U equals to Q minus W. So some of the textbook, you might be encountering this, but in our textbook, which is the Gann-Collie, this is the formula for the first law of thermodynamics, right? So you can use either one, it will be the same. However, the things that I would like you to put in mind or to remember is the sign convention. So I put 3 stars again, means it is super duper important. Okay, so now let's look at the sign convention one by one. Yeah, change in internal energy. Just now we look at U, right? U is the internal energy. So if you put a delta in front, it means the change. Delta means change. So change in internal energy means final internal energy minus your internal energy. So if you have a positive sign for change in internal energy, it means there will be an increase in temperature, right? So if you still remember, internal energy equals to 3 over 2 nRT. So change in internal energy is actually equals to U final minus your U initial. So plug in with the value 3 over 2 nRT final minus 3 over 2 nRT initial. So simplify, you get T final minus T initial. So if you get a positive value for this, it means your final temperature is higher than the initial temperature, correct? So likewise, if you get a negative value for change in internal energy, it means your initial temperature is smaller than your final temperature. Okay, as for heat, positive Q means the heat is absorbed by the gas. Okay, the heat is absorbed by the gas. So negative Q means heat loss. NR is a constant. NR? Yeah, that one is from your ideal gas equation. Okay, huh? Right. And lastly, for work, okay, positive means work done by gas, which is expansion, or we can say there will be an increase in the volume whereby the final volume is larger than the initial volume. Negative work done is compression. So compression means final volume is smaller than initial volume. Okay, so I give you 1 minute to memorize all this. 1 minute. Memorize the sign convention. Okay, so now without looking at the notes, so go and hide all the notes away. I would like you to write down what is the sign convention, including the explanation of each term. Okay, so you can use a handphone to scan the QR code or go to this link. Have you scanned the QR code? Nah, scan first. And fill in the blanks in the table. can give link, I can. Wait, I guess I will just... Oh, you see a lot of animals here. Why is it so slow? Okay. Anonymous turtle, hold on, don't fill in the the process, the thermodynamics processes. This turtle is moving very fast. Okay, thank you. Alright, so fill in the first part only. Then later on, we will write together on the second part. My laptop overheated again. Okay, so let's look at the... Okay, this is our collaborative work. Okay, so let's revise. Delta U means change in internal energy. So if it is a positive sign, means there is an increase in temperature. Right? Negative means decrease in temperature. Very good. Q refers to the heat energy that's supplied. So positive, it will be heat absorbed or heat gain. Negative will be heat loss or heat release. So an additional question. You have learned in your chemistry about what? Endothermic and also exothermic processes, right? So positive Q, is it exo or endo? Endo. Can you write down into the Google Docs? Just write down. You can put a bracket. So write down bracket. Yeah, and heat loss is exothermic, right? And work done. Okay, so for W, it's work done. So positive means expansion, which is work done by gas. Negative means compression, which is work done on the gas. So it will be the surrounding who is doing the work. Okay, thanks. Now let's move back to our slides. Okay, so please remember what you have written down today, and remember until until your degree, yeah. Okay, but if you are a chemical engineer, so this will be in your mind forever. Alright, so this is an extension also. Okay, if you still remember, yeah? So all of you, you are very young. So by right, I guess the question is familiar to you. Okay, so we have already answered those front part in your semester 1. Now let's look at the syllabus in your semester 2. So these are the question. Okay, so initially we have the information. Okay, the gas in the cylinder has a volume, so the volume, initial volume, is 1.6 times 10 to the power of negative 3 meter cube. At a temperature of 30 degrees Celsius. 30 degrees Celsius is how many Kelvin? 300. Yeah, correct. Okay, 303 Kelvin. So the gas is heated to a temperature. So that is your second temperature. Okay, so T2 is 90 degrees Celsius. And expand under a constant pressure. So that will be your P1. And it is also equals to P2. So calculate the volume of the gas at 90 degrees Celsius. Alright, so given the ideal gas law, there are 3 laws, right? Charles' law, Gay-Lussac, and another one is what law I forgot, right? But in O, we know that P1 V1 over T1 is equals to P2 V2 over T2, right? So given here, P1 is equals to P2, so these two can cancel out. So we can summarize V1 over T1 equals to V2 over T2. So we have V1, T1, T2. Can we find V2? Yes, we can. Okay, so V1, 1.6 times 10 to the power of negative 3. T1, okay, 30 plus 273. V2 is our unknown. T2, 90 plus 273. So we get 19 times 10 to the power of negative 3 meter cube. And now calculate the work done by the gas. Okay, so just now our work done is equals to pressure times the change in volume. So since pressure is constant, so 1.1 times 10 to the power of 5. Change in volume will be 19 times 10 to the power of negative 3 minus the initial 1.6 times 10 to the power of negative 3. Yes? So it will be 33 joule. That one is from your ideal gas equation. If you would like to find the volume, okay? Here, yeah. Okay, if you still remember your ideal gas, right? PV equals to nRT. So if the gas does not change, let's say if this is your gas, it's in a closed system. Closed system means the molecule inside are not allowed to go out or go in. Okay, a closed system. So your number of mole and your R will be constant, correct? So that's why based on the three law, if you still remember, I forgot one of those. It's Charles' law, Gay-Lussac law. Which another one is what law? Okay, so
Boyle's law.
Boyle's law, huh? Yeah. Okay, so from these three, we actually can conclude your P1 V1 over your T1 is equals to P2 V2 over your T2 when we combine these three laws together. Okay, so it's same, yeah? So when you change the property or you change the state, so this is what we call as states. When we change the states of the gas inside, okay, let's say now if I when I increase the volume, let's say, but if I maintain my pressure, so what will happen to my temperature? It will be decreased. Okay, so this is what it means by the relationship from these three laws. Okay, so when it comes to ideal gas, okay, if you are asked to look for the states of the gas, what you can do is you can actually start from this. Okay, so next move on to our first law of thermodynamics. So how does this first law of thermodynamics equation is being used? Okay, so check on the sign convention also. So an amount of heat equals to Q 2005 joule is added to a system. Added means heat is being supplied, so it's positive Q. And 1008 joule of work is done on the system, means the work is done on, so it means it is negative work done. So what is the change in internal energy of the system? Okay, so from your first law of thermodynamics, delta U equals to Q minus W. Q is positive, so just write down positive 2005, negative minus your work done, which is now negative 1008. So you will get 4003 joule. So this positive value means your temperature increases at the end of the process. Now look at question B. So what will be the internal energy change? So now if the heat is added to the system, so added means positive, and now the work is done by the system, so which means this is positive work done. Okay, so let's calculate our new delta U. So positive work done, so 1008, and it will be 700 joule only. So 700 here means your temperature increases or decreases? In or D? In increases or decreases? It is increases, right? Increases, huh? The value is lesser, but however, if you look at the total process, it is still positive in value, so the temperature still increases. Okay, so look at the four thermal processes. In thermodynamic processes, okay, so these are the four common processes that it's involved. So we have isobaric, comes from the word bar. So bar is actually a unit for pressure measurement, just like your Pascal, your ATM. Okay, bar is also an American's units of pressure measurement. Okay, so ISO means SAM. So means SAM pressure. Okay, so if it is an isobaric process, means the pressure remain the same. Okay, your pressure remain the same. Initial pressure equals to the final pressure. Okay, isochoric means constant volume. Okay, initial volume equals to final volume. So if you still remember from work done equals to pressure times the change in volume. So when change in volume equals to 0, your work done is also equals to 0. So if it is an isochoric process, no matter how much the change in the pressure or temperature, there is no work done because there is no displacement. All right, isothermal means constant temperature. All right, so if your initial temperature is equals to final temperature, means there is no change in temperature. So in another way, we can say that no change in internal energy as well, right? Because change in internal energy is equals to change in temperature. Last one, adiabatic. So adiabatic, no heat transfer. Okay, when your Q is equals to 0, thermal energy is heat. So again, this is something that I would like you to memorize also, right? So how do we memorize? Okay, the first one, bar means pressure. Okay, because bar is an unit measurement of pressure. So if you saw isobaric, so this is constant pressure. All right, and usually students will confuse with isothermal and adiabatic. So how I usually remember is, again, I look at the T here. Okay, isothermal T means T is constant. Okay, so that's why it is T stands for temperature. So temperature is constant. All right, and for isochoric, this is a bit doesn't related with the volume. However, this was invented by the previous semester student. All right, so what they do is they mention about, okay, miss, we have isobaric, isothermal, and the third iso is isoclever. C stands for isoclever. So in Mandarin, usually when we say someone is boasting, we say that they are choi soya, means they blow water like they are boasting. So sui sui means something related with volume. Okay, so this is how they actually remember isochoric as in the sense of constant volume. And the odd one here out is adiabatic. So adiabatic does not related with any of the states. Okay, so if you look at these three iso, right, they are all related with your states, PVT states. Okay, so these three iso is for the states. So another one that is the odd one out here, it does not related with the state, but it relate with your Q, which is the heat. Okay, so again, spend some time to memorize all these four. Okay, so I give you 30 seconds. No sound, yeah, because I give you time to memorize these 4 thermodynamics processes. Have you memorized? Okay, so if you would like to plot them in the graph, okay, in thermodynamic processes, when we want to plot them in graph, it's usually the graph of states. What do we mean by graph of the states? It will be either PV, for those other than isobaric, all the pressure we apply will be the final pressure. No, if it is not isobaric process, then you have to apply both the P1 and P2. Okay, so we will look at the example later on. Yeah? Only isobaric process, okay, you can use the same pressure because the pressure doesn't change, right? Okay, so the graph of states will be either PV or P versus T or volume versus T. Okay, so it's actually again something that related with your Charles law lah, your Gay-Lussac law lah, your Boyle's law lah. Okay, so again, a good news for you, in your syllabus you will only encounter PV graph. Okay, PT or VT graph, that one you will encounter in your degree. So we will only introduce to you PV graph. Okay, so if you are plotting isobaric process in PV graph, is very easy, just a straight line, a horizontal straight line like this. So this is what we mean by isobaric process. Okay, so your value of P is constant. What will change? Your volume will change. Okay, or it can be final here or initial. Okay, depends on the process. If it is an isochoric process, then it's a vertical line. So your volume is here, okay, equals to the initial volume, and it's also equals to the final volume. As for isothermal and adiabatic, they are not the same. Okay, so a lot of us we will think, oh, when there is a change in heat, when there is heat, definitely there will be a change in temperature. So this is what we usually understand. However, when it comes to some processes, okay, we might encounter isothermal or we might encounter adiabatic. So isothermal processes, it takes place very slowly, okay, and the system must be in thermal equilibrium with its surrounding. Okay, so which means your temperature is the same. All right, so an example of this one, if you have remember, okay, it happens when the ice is melting, right? Correct? Or it happens during condensation. Remember? Your temperature is the same, but there is a change in the heat. Okay, so during the process, it reached thermal equilibrium, whereby the temperature at the surrounding and the system is the same. However, there is a heat exchange. Okay, so this is an isothermal process. So it did happen when there is a change in heat, there is no change in temperature, right? So this happened very slowly, right? Because the temperature does not change. Okay, and as for adiabatic process, so it happened very fast and there is no heat exchange. However, there is a change in the temperature. So usually this one happen when it is well insulated. All right, so means let's say if you have a bottle here, okay, and you insulate them, so it will prevent the heat from entering or going out. Okay, however, there will be a change in the temperature inside. Right, so there is no heat going in or going out. So if you have to plot them into the PV graph, so usually how do we differentiate between the two graphs? So the difference here is your adiabatic graph, it will be steeper as compared to your isothermal graph. Okay, so if you look at here, this one is again steeper. So both of them, they are not a straight line, but there must be a curve going down like this, okay, or going up, okay, but the difference is your adiabatic will be steeper as compared to your isothermal. Okay, so now, can you tell me? Yeah, this is a temperature versus volume graph. So what is the process? Look at the axis, temperature versus volume. What? Yeah, B, huh? So if you look at here, temperature is constant. Your temperature is constant. So if temperature is constant, it will be isothermal. So how do we know whether it is an expansion or compression? Look at the arrow. So arrow here means here is initial, here will be final. So if the volume is decreasing, then it will be compression. So it is isothermal compression. Answer is B. How about this? Okay, correct. So it will be isobaric expansion. Okay, your pressure is constant. So volume increases means it is expansion. Okay, so now it's your show time. Go to the same link again or the same page. Okay, and I would like you to, without looking at the notes again, fill in the 4 thermodynamics processes and also the description. Okay, move now. Then we will see a lot of animals is typing on the Google Docs. This is a zoo. We have a zoo. We have a zoo in the Google Docs. You can write down as many descriptions as possible. How does it link to your first law of thermodynamics or link to the ideal gas? Okay, so let's look at your explanation. So as the first one, isobaric. Okay, isobaric, constant pressure, correct? Yeah. So what will be the work done for isobaric? Can anyone write down what is the formula for work done if it is an isobaric process? Do you know where to find the delta? You can go to insert, here on top, insert, special characters, and you can find the delta there. Yeah. Okay, so for isobaric process, work done is equals to P times delta T. Okay, so isochoric, constant volume, so the work done is equals to 0. So perhaps you have to delete the work done by gas. Don't have to specially mention it is either work done by gas or on gas. Just write down work done. Yeah. So work done will be equals to 0 because there is no change in volume. Next, isothermal means constant temperature. Initial temperature equals to final temperature. So this also indicates that the change in internal energy is also equals to 0. Right? Thermal equilibrium means the temperature is the same. Okay, lastly, adiabatic, no thermal energy transfer, or in another word is no heat loss or heat gain. Okay, no heat transfer at all, so Q equals to 0. Right, very good. Okay, so let's take a break before we move on with more calculations. So we will come back again at 11:05. Alright? So please go and eat something or go for washroom. Okay, see you later. Okay, there is a question about the previous topic about buoyant force, huh? So why is it buoyant force always moving upwards? Okay, it's always moving upwards, yeah. Why? Because it is because of the pressure. Let's see if I can. It's because of the pressure, huh? So, whether it is underneath the water or here in the atmospheric pressure, okay, but usually we will feel the difference in pressure when we are under the water, right? So what happens is, if you have something down into the water, on top of the object will be feeling a pressure of P1. At the bottom of the object, there is another pressure which is P2, right? So can you tell me, it's P1 larger than P2 or P2 larger than P1? It's definitely P2 larger than P1, right? Because H2 is larger than H1. So if you have okay, let's say on these two sides, yeah? Okay, if P2 is larger than P1, so where will be the direction of the force that you feel, right? It will definitely from P2 going to P1, right? So that's why this is actually because of the difference in pressure. So because of difference in pressure, there is a force that is being exerted because of the difference in pressure. So that's why your buoyant force is contributed by this. Okay, so buoyant force is always going upwards, right? Okay. Okay, so have you all come back already? Okay, so thank you for replying, and let's move on to our lecture today. Okay, so what actually the thermodynamics, with the knowledge of thermodynamics, what can we do? Okay, so if you have discovered, yeah, the cyclic process, especially our aircon, how does it work, is a result of the study in thermodynamic processes. So this is an actual cyclic process that happened in the engine. Okay, so cyclic process means the system starts and returns to the same thermodynamic state. So means your P initial will be equals to P final, V initial equals to V final, T initial equals to T final. Okay, so usually a typical graph of of a cyclic process. So let's say we have P versus V. So if you want to draw this graph, here, okay, so expansion at constant temperature. So this is isothermal expansion. So you can draw a curve, isothermal expansion. Okay, process 1. Isochoric process, so removal of heat at constant volume. Okay, isochoric process means same volume. Isothermal compression, again, go back, isothermal compression. And finally, isochoric process. Okay, so if you look at this, it starts at this point and end at the same point also. So this is what it means by cyclic process. Okay. So let's try on the work example. In an engine, 0.25 moles of the gas in the cylinder expand, means work done by gas. And adiabatically, Q equals to 0. So in the process, temperature drop from 1150 Kelvin to 400 Kelvin. So this is your this is T initial and this is T final. How much work does the gas do? Assume the gas is ideal. Okay. So 0.25 is the number of moles. So let's solve this question. Okay. In order to find the work done, okay, work done can be found from P times the change in V, or it can also be found from first law of thermodynamics, right? Delta U equals to Q minus W. So in this case, we cannot use this one because we do not have information about the pressure. So another resolution will be from first law of thermodynamics. Okay, so we have to find what is delta U first. So delta U is the change in internal energy, U final minus your U initial. U is equal to 3 over 2 nRT. So T final minus T initial. Number of mole 0.25. R gas constant 8.31. Final, which is 400 minus 1150. So again, I know it is somehow a bit contradict with our logic when we need to minus something with a bigger number, especially when 400 need to be minus with 1150. It's against our logic, yeah. However, for physics, it's always follow the sequence. So when we write down final minus initial, you just follow the sequence, right? 400 minus 1150, okay? So it will be in negative value. It's okay, okay? Because heat is lost from the system. So you get negative 2003 joule, okay? So that is your change in internal energy. So from your first law of thermodynamics, plug in the value with the sign. Q is equal to 0 minus W. So your work done is 2003 joule. So it's an expansion. So verify your answer that it is an expansion process. Okay, so the working is here. And now, what if we have a long question like this? Okay, a combination of ideal gas, of first law of thermodynamics, and also the 4 processes. Okay, so this is what usually you will encounter in your exam, whereby you have to fill in a table. Okay, so let's do them together one by one. Yeah? It's a cyclic process. So when it comes to cyclic, it means perhaps the whole system is equals to 0, right? If you still remember, your P initial equals to P final, V initial equals to V final, and T initial equals to B final, which means your delta U of the whole system initial final, here when it comes 1 to 2, 2 to 3, and 3 to 1, when it backs to here, your delta U for the whole system is actually equals to 0. right? Undergo by 1 mole. So this is your N equals to 1. And given the temperature at T1 equals to 300 K, T2 600, and T3 455. Find what are the Q, delta U, and W. So complete the table here. Okay, so if your temperature is given, can you find your value of U? Can, right? So to find the value of U, U1 equals to 3 over 2N R T1. So this is your T1 and you get 3740 joule. Unit is here, so you don't have to mention your unit in your table again. So can you do the same for U2 and U3? And you tell me the answer on the chat. Yeah? What is the value of U2 and what is the value of U3? U274 at 0. Very good. How about U3? Five, 6, 7, 0. Okay, thank you. Okay, so let's move on to complete the table of first law of thermodynamics. So from process 1 to 2, what is this process? We have
Static.
Correct, because 1 to 2 is constant volume. Yeah. Okay. So how to find the change in internal energy? Is equals to final minus initial. So U2 minus your U1. U2 minus U1. 74 at 0 minus 3740 is equals to 3740 in positive value. Yeah. Okay, so since it is isochoric process, so work done equals to 0. So can you find your heat or thermal energy? Yes, huh? Okay, delta U equals to Q minus W. So 3740 equals to 0 minus W, and W equals to
Yes, isn't it Q minus 0?
Sorry?
Isn't it Q minus 0?
Sorry, Q minus 0, W minus 0, Q minus 0. Q is equals to, oh sorry, yeah. 3740, or Q is what we need to find. Yeah, so Q equals to positive 3740. Thank you. Okay, so can you find delta U for 2 to 3? What is delta U23?
Negative 1,800.
Negative 1,000?
810.
Or 810, huh? Yeah. How about delta U 3 to 1?
Negative 1,930.
Okay, negative 1,930. Okay, so given 2 to 3 is an adiabatic process, so it means Q equals to 0. So we can find our work done from the first law of thermodynamics. Work done positive 1810. Okay, so 3 to 1 is an isobaric process because the pressure remains constant. So in order to find the work done is equals to P times change in volume. So work done from 3 to 1. Alright, so P remain constant, so change in volume, it will be final volume, which is volume 1 minus volume 3. Okay. However, for this case, again, we do not have the information for volume, right? So how do we find the work done? Okay, so it links to your ideal gas equation. P V equals to N R T. So since N R is constant, so the only thing that can change will be your pressure, right? So V1 minus V3, so it will be NR T1 minus T3. So from there, our work done will be negative 1290. So from the value that we found, we can find our Q again. Huh? Okay. So if you look at the last column here, 1 to 2 to 3 to 1, so means this is a closed cyclic process, the whole process. So how to find the whole system, the delta U of the whole system is basically the summation of all delta U from 1, 2, 3 to 1. Okay, so is equals to 3740 plus negative 1810 plus negative 1930. So at the end, you will discover it's just equals to 0. As for the total summation of work done, it will be equals to positive 520. And for the Q is positive 520. So, okay. So at the end of the cyclic process here, if you look at here and double check with your first law of thermodynamics, Q 520 minus your W, which is 520, And indeed, the whole system, okay, delta U of the whole system is equals to 0. Okay, so if your calculation is correct, yeah, at the end when you double check with the checking, you will still get the correct answer, right? So this is what we means by when we are having cyclic process, yeah? Your delta U of the whole system will be equals to 0, but it doesn't mean that your work done and also your heat exchange will be 0 as well, okay? But definitely your delta U will be 0. Okay, so I move on. Next question, if the initial pressure at point 1 is 1 atm, what are the volume and pressure at point 2 and 3? Okay, so to find the volume, we have to find P2, V2, P3, and V3. Okay, so just now what we have is at step 1, P1 is given, which is 1.013 times 10 to the power of 5 Pascal. The temperature is also given, right? Temperature from the previous question that we have done is 300 Kelvin. And in your step 2, P2 we have to find, but T2 is also given, which is 600. So we can find our P2 because volume is just constant. It's an isochoric process. V1 equals to V2. So we have P1 over T1 equals to P2 over T2. Plug in the value. P2 is 2.03 times 10 to the power of 5 Pascal. Okay, so P2 we have found the value, and P3 and P1 will be the same because it is isochoric process. So it will be equals to 1.013 times 10 to the power of 5 Pascal. Now to find our V2 and V3. Okay, because V1 is not given, okay, you can either find with first law of thermodynamics, okay, you can find with either by using ideal gas law since you have P2 V2 equals to nRT2, right? You can either use with this, or we can use what we have learned today by using internal energy. Okay, so we can divide into two groups, okay, to find, so you can find with two types of methods. So this method one you have learned in your semester one. So I will go through what we have learned in semester 2 with you today. Okay, so we have already known that internal energy equals to 3 over 2 nRT, right? And is also equals to 3 over 2 PV. So in order to find our V2, okay, we can find from U2. 3 over 2 and our T2 equals to 3 over 2 P2 and V2. So from our previous questions, U2 is 474 at 0. P2 2.03 times 10 to the power of 5 V2. So V2 0.0246 meter cube. So use the same method to find our U3. So V3 is 0.0374 meter cube, right? So you can also double check with SEM1 method to see whether or not you can get the same value. Anyone have tried? talk here. Okay, if you like, you can come, then it will be easier for me too. Okay, have anyone tried with option 1? Do you get the same value? Same, huh? Okay, yeah. Okay, so that's why when I study my thermodynamics in my degree also, that is the only unique, because it's very difficult to understand, because there are not a lot of things that we can visualize or we can really experience in our daily life. So especially there are some thermodynamic processes, it only happen in the factory. So because it's not so common, that it's very difficult again, like for us to visualize what is actually the process. However, the calculation part, you know when you are correct. Because why? Because when you are, as long as when, again, just like what happened in our simple harmonic motion, when the concept is correct, right? So no matter which method that you have used, okay, it will bring you to the same value. So you know when you are correct, even though you might find it very difficult to understand. Okay, so that is the magic part for thermodynamics. So any more questions for this topic? If no, then I will give you a short Kahoot session. Just to test your understanding. Previous slide. This one. Is it? So while waiting, can you go to Kahoot? Okay. Done the slides? Okay. So on your device, go to kahoot.it, huh? And log in with the game pin. You are allowed to generate your own creative maps, as I have promised last time. Okay. Are you allowed to generate your own map? No, also set already. Next time. I think I forgot to change the setting. You can invite your granny to answer together with you. On your browser, type this one, www.kahoot.it, and you will be prompted to enter the game pin. So you enter this number. Can I start now? Done? Okay, so we will be starting in 3, 2, 1. I guess a bit. Yes, it is negative. Huh? When the gas is being compressed, means the surrounding is doing work on the gas. So it's negative value. Lagging ha. Game ping here. Han 5297676. Ha. Thank you for putting the pin on the chat. Huh? So let's try the next question. Is it lagging from my side? Lagging for you to see the question, is it? Okay. So when the heat is released from the system to the surrounding, Q is, red color is heat loss, blue color is 0, yellow color negative, green color positive. When the heat is released from the system, which one should be the Okay, so the heat released means Q is negative, okay, based on the sign convention. Okay. Did you manage to answer this time? Okay. So I will read the question now in case it doesn't show up on the screen. So question 3, which thermodynamic condition will result in delta U equals to 0? Red color, isothermal, yellow color, isobaric, green color, reactive. Okay, isothermal will result in delta U equals to 0. Okay, delta U is equals to 3 over 2 NR delta T also, right? So if T is constant, means there is no change in delta U. Wow, wise falcon. Yes, แอดแล้ว Okay, for fourth question, in an isothermal process, red color, Q doesn't equals to 0, but delta T equals to 0. Blue color, Q equals to 0, delta T equals to 0. Yellow color, Q equals to 0, delta T doesn't equal to 0. Green color, Q doesn't equal to 0, delta T also doesn't equal to 0. Okay, very good. So it's red color. Q doesn't equal to 0, but your delta T equals to 0. Isothermal means T is the same. Funny roster. How does the volume of the gas related with the temperature under isobaric process? Volume related with temperature. So red color always the same. Blue color hard to tell. Yellow color directly proportional. Green color inversely proportional. Okay, so this one is from your ideal gas law, right? Isobaric condition means P constants. So if your P remain constant, then your volume and temperature, isn't it directly proportional? But my screen is lagging, right? Okay, so from your PV equals to nRT, if your P remain constant, how does V related with T? So if your V increases, T also increases. That's why they are directly proportional. Alright? So let's see the result. And review yourself. Sorry, this is how to do an eager at red. So these are the aspects that you can refer to in this question in this topic. So review yourself in the chat, okay, which procedure you have, and be ready to receive consultation from your friend. Alright, so thank you for your participation today. Okay, and I shall meet you again on Thursday. Tomorrow it's a public holiday, so I have already have a pre-recorded. Sorry, because of the delay in the screen. Okay, so please go through the online pre-recorded video for the tutorial workshop session, right? And we shall meet again on Thursday for the clinics. And your midterm will be next week, so I will send a separate announcement about the midterm again somehow end of this week. So the mode of the exam will be the same as your semester 1, right? So I guess you are quite familiar already. But what you have to do is, again, a reminder is you must study. Okay, do not think it's an open book and you don't have to study, because again, open book doesn't mean you will get the same the easy question as in the closed book exam. Open book, it will be something that needs you to think, and most probably it will be more to application and explanation. So the example of the questions that given is just like the weekly challenge question, something like that. All right, so if you do not study, you won't be able to know how to answer them, because it needs to apply. It's actually the application types of questions. How long? 4 hours, just like in your midterm last semester. Okay, and again, another reminder, a very important reminder, is to uphold your academic integrity. Okay, I know when you copy, and I know when you discuss with your friend. Okay, because I was a student before. I know how the student think, and I know your how to say, I know which one is your work and which one is not your work. Okay, based on how you answer questions. Okay, and again, this is what the last semester student, they asked me, Miss, how do you find out if we actually discuss or we cheated? Then I told them, if I cannot discover, then I won't be your lecturer now. Oh, so this is something that I would say the sense that a lecturer or a teacher will get when you become a teacher later. Okay, so even though I really wish you can score well, but I hope it's from your original work. This is the best the best rewards that you can give to a teacher, is just by like really, when you can really understand and you can do it with your own effort. Okay, and this is also something that you can tell your children later. Hey, I score very well, I never cheated in class. This is something that is very proud of to tell. And it actually reflects your personality and your integrity. Okay, so I hope and I trust that you can uphold them. All right, so that's all for today, and happy holiday tomorrow, and see you on on Thursday, chemistry at 12. Okay, and so you can